Today I'll talk about Pitot tube. Now what is the application of Pitot tube? So Pitot tube is used for measuring the velocity of the liquid flow at any point in the pipe or a channel. So Pitot tube is used to measure the velocity. Earlier for orifice meter and venturimeter, there we used to measure the volumetric flow rate. Now Pitot tube used to measure the velocity of liquid flow at any point in the pipe or a channel. Now what is the principle behind that Pitot tube measuring velocity? So if the velocity of the flow at point becomes zero, the pressure is increased due to the conversion of kinetic energy into the pressure energy. Based on this principle, we can calculate velocity. Here again, if the velocity of the flow at any point becomes zero, the pressure is increased due to the conversion of the kinetic energy into pressure energy. This is important. So based on that, we can easily calculate the velocity. The point at which the velocity of the flow becomes zero is called stagnation point. The pressure at the stagnation point is called total pressure or head, and or you can say the stagnation pressure or head. So now here you can see this is the Pitot tube. Now when that flow is flowing through the Pitot tube at this point, what will happen? The velocity becomes zero and that pressure will increase. That pressure is called total pressure, or sometimes we call that stagnation pressure. Now what is that Pitot tube shape? The Pitot tube consists of an L-shaped glass tube, a tube bent at 90 degrees with the open ends. The horizontal part is called that stem. That horizontal part is called body and vertical part is called stem. So this is called body, this is called stem, and which that stem is open to the atmosphere, and this Pitot tube is placed in the different position of that pipe and channel. From there we can easily calculate, based on that height difference, we can calculate the velocity. Now here in the Pitot tube design, so that Pitot tube is placed in the center of the pipe. So here P1 V1 is the pressure and velocity at the point 1, P2 V2 is the pressure and velocity at point 2, H is the depth of the tube in the liquid or depth of the points A and 2 from the free surface of the liquid. Now this is okay, so this is H, so from that surface to the center point, so that is H. So H we can vary, based on that we can also calculate the velocity. And H is the rise of the liquid in the tube above the free surface of the liquid, and or not free surface, this is actually enclosed pipe, so from this pipe wall we can say. Rho is the density of the liquid and G is the acceleration due to the gravity, and Z1 Z2 is the datum head at the point 1 and 2. Now apply the Bernoulli's equation at point 1 and point 2. So we know the Bernoulli equation, P1 by rho G plus V1 square by 2G plus Z1 is equal to P2 by rho G plus V2 square by 2G plus Z2. Now the datum head, so if we consider this is the datum head, okay, so the center line, so Z1 is equal to Z2. At stagnation point here, that V2 is 0, so that V2 is 0, Z1 Z2 will be cancel out. Okay, so now we will give that equation become, so Z1 is equal to ZD and Z2 and V2 is equal to 0, so P1 by rho G plus Vn square by 2G is equal to P2 rho G. Pressure difference here we can consider P1 by rho G minus P2 by rho G is H, so we can write that P1 by rho G is equal to P2 by rho G plus H. So now here if we plug that, so V1 square by 2G will be H, so V1 will be the root over of 2GH, means if we know that H, we can easily calculate what will be the V1. Okay, now here the actual velocity considering the coefficient of the velocity, so V actually will be CV into root over of 2GH. So here CV is the coefficient of Pitot tube, typically range 0.96 to 0.99. So now we know the V actual. So now ultimately the velocity equation, the velocity fluid flow at any point of the channel measuring by the Pitot tube is given by V is equal to CV into root 2GH. Now application, so Pitot tube is also used for measuring static head, dynamic head and stagnation head or total head of the liquid flow at any point of the pipe of a channel. So you know the static head is nothing but P1 by rho g, and dynamic head is V1 square by 2g. Remember that, we can easily calculate. So I think remember that application Pitot tube is also used to measuring static head, dynamic head and stagnating head, as well as the velocity at at any point of the pipeline or channel. So we can measure velocity here. Now if I have all this data, so we can get the velocity profile. So Pitot tube, by using Pitot tube we can also draw the velocity profile. So that's it. Thank you.